Hello everybody, I would like to welcome you to our 12th video in the pre-algebra playlist. And in this video, we are going to go over the topic of simplifying expressions. In this video, we are pretty much only going to deal with variable expressions. So now, before we get started, I would like to take a look at an example of a variable expression and go over different parts of a variable expression that we have pretty much not defined yet. So here I'll write down the variable expression that we will talk about. In this case, my variable expression is a plus 2b plus 3c plus 4d plus 5. Now I could write a 1 over here and read this as 1 times a plus whatever, but in mathematics it is common notation to simply not write the 1, and it is assumed that we are multiplying a variable by a 1 if there is no coefficient or a number in front of it. So one of the first words that we will look at when it comes to identifying parts of a variable expression is the word constant. So before we begin defining parts of the variable expression, I would like to tell you that in any variable expression, no matter what kind and what numbers are used, there will be 3 parts to it. One of the first parts to a variable expression will be that it consists of a constant. So, a simple or basic definition of a constant is that a constant is any number in the variable expression that is not being multiplied together with a variable. So if you think about it, a constant is just a number that is all by itself. In the above variable expression, what is our constant? We know that any letter cannot be a constant because a constant is defined to be a number. So we know that A, B, C, and D cannot be the constants. Also, we know that the 1 in front of the variable A cannot be a constant because it is being multiplied together by the variable A. Similarly, the 2 cannot be a constant because it is being multiplied to B. Same goes with 3 because it is being multiplied with C. And 4 is being multiplied by D, so that cannot be a constant. On the other hand, the 5 is a number that is the constant. This is because 5 is not being multiplied together by any variable. Therefore, 5 is an example of a constant in the above variable expression. Now, a second part of any variable expression will be what is known as a coefficient. Now, a coefficient is simply the number that is in front of the variable. Basically, it is the number that you multiply the variable by, and it is right in front of the variable itself. So, if we look at the variable expression above again, what is an example of a coefficient? Or more appropriately, what are the examples of coefficients? If you think about it, the 1 in front of the A is an example of a coefficient because that is a number in front of the variable and you're multiplying 1 and A together. So 1 is a coefficient in the above variable expression. Similarly, 2 is being multiplied to the variable b, and it is in front of the variable b, so 2 is a coefficient as well. Similarly, 3 and 4 are also coefficients in the above variable expression. Now in mathematics, if a number is a constant, then it is not a coefficient. Similarly, if a number is a coefficient, it cannot be a constant for the same variable expression. Therefore, 5 cannot be a coefficient because it is not being multiplied to any variable. So 1, 2, 3, and 4 are my coefficients for the above variable expression. Lastly, the third part to any variable expression is known as a term. A term is basically the combined product of a coefficient and a variable. Therefore, if you look at the variable expression above, all we really need to do is find where there is a combined product of a coefficient and a variable. 1a, or simply a, is a term because that is a product of the coefficient 1 and the variable a. Same goes with 2b because that is a combined product of the number 2 and the variable b. Same thing goes with 3c and 4d. So my terms in this variable expression above are a, 2b, 3c, and 4d. Now before we move on to simplifying variable expressions, I would like to go over one more thing. If I had the variable expression similar to the one above over here, but instead of all the pluses, I had the minuses like this over here, then my coefficient would not be 5, but it would be -5, because I need to account for the negative out in the front. Similarly, the coefficients would be the numbers +1 because there is no negative sign over here, and -2 along with -3 and -4. And similarly, my terms would be +1a, -2b, -3c, and -4d. So now let's go over 3 examples in this video where we go over how to simplify variable expressions efficiently and properly, and that'll be it for this. In this first example, all I really want to do is simplify the variable expression 4b plus 3b. Now, if this is the first time you're simplifying variable expressions, one of the best ways to think about approaching the simplification of a variable expression problem is to think about the word family. Now, you probably heard in your life that family is the most important thing in the world, and when it comes to math and especially simplifying variable expressions, that is pretty much true as well. So what I mean by that is you can think about the variable b over here as the last name of the term. So if my name is 4b, then 4 is pretty much my first name and b is pretty much my last name. Similarly, if my name is 3b, then my first name is 3 and my last name is b. Now, a family is pretty much identified by its last name. So if you're probably confused, then you're probably wondering how you can possibly combine two terms together, such as 4b plus 3b. We can break it down into a few easy steps. The first thing that you need to do is understand how many and what variables will be in your final answer. Now, if all the terms contain the variable b and only the variable b, you will only end up with a variable b out in the end. The only thing that you need to find out now is what will be my first name of the answer, or pretty much what will be the coefficient of the term. In order to figure that out, all you really need to do is perform the appropriate operation with the coefficients of the two terms present in the problem. So, the coefficients that I have at hand are 4 and 3. The operation that I need to perform with 4 and 3 is that of addition because I have an addition symbol right in the middle of 4b and 3b. And what I get when I do 4 plus 3 is the number 7. So 7 is the number that I will simply put in front of the b over here. One of the other ways to think about this problem is to refer back to a few videos when we went over how to multiply integers. We define multiplication as a repetition of addition. So if I say 4 times b, that is the same thing as saying adding b to itself 4 times, like this over here. And to 4b, I'm adding 3b, that is the same thing as saying adding b to itself 3 times, like this over here. Now all you really need to do is figure out how many b's you're left with. So I'm left with 1, 2, 3, 4, 5, 6, and 7 b's in total. Therefore, my answer to what is 4b plus 3b is 7b. Now let's do another example. Let's say in this example, I have 3x plus 4b minus 7b minus x, like this over here. One of the ways in which you can approach the simplification of this variable expression over here is by bringing the families together. You realize that you have a family of x's and you have a family of the b's over here. Since one b and one x cannot be combined together because they're from different families, we need to combine the x's together and we need to combine the b's together. We essentially need to take the term negative x and move it right next to the x. And when we do that, we get the following variable expression. All I did was that I simply copied and pasted the term negative x and moved it right next to the 3x because I need to combine all the x's together and I need to combine all the b's together. Now I can do 3x minus x, and when I do that, I realize that my coefficient over here is a 3 and my coefficient over here is a 1. The operation that I need to perform to 3 and 1 is that of subtraction due to the subtraction symbol over here. So 3 minus 1 will give me a 2. And since the variable at hand is that of the x, I need to write the x right by it. I do the same thing here with the 4b and the negative 7b. And since I'm talking about the variable b, I write the b over here. Now, I'm left with 2x plus negative 3b. Going back a few videos, we learned that when you add a negative number, that is essentially the same thing as saying subtracting the absolute value of that number. So I can rewrite 2x plus minus 3b as simply 2x minus 3b. So in this third example, let's say I have the following expression that I need to simplify, and let's just go all in. One of the first things that we need to do is simplify whatever is inside the brackets over here. And in order to do that, we need to simplify what is inside the parentheses over here. Now, I write the two families of the j's right next to each other by simply moving the negative 4j right by the 2j. I now deal with the coefficients of the j's. I have the coefficient of 2 and I have the coefficient of the 4. The operation that I'll be performing is that of the negative, and when I do 2 minus 4, I get negative 2. Since the variable that I am dealing with is the variable j, I'll simply put the j over here. Then I simply add the 3k to it. So the inside of the parentheses can be simply simplified into negative 2j plus 3k. Notice that negative 2j plus 3k is equivalent to 3k minus 2j because I simply just moved the negative out in the back. The next thing that we need to do is simplify whatever is inside the brackets. We realize that we are dealing here with the distributive property. So I need to multiply 6 with this whole term 3k, and from it I need to subtract the product of 6 and this whole term 2j over here. I can rewrite this expression over here like this over here. So 6 times 3 will give me an 18, and 18 times k will give me an 18k. Similarly, the 6 times 2 will give me a 12, and 12 times j will give me a 12j. I now simply put the negative sign between 18k and 12j. Now I can rewrite the above expression over here like this down over here. Now if you think about it, you're essentially multiplying 18k minus 12j by negative 1. So we need to use the distributive property one more time. I can rewrite my expression over here like this over here. Then I can use the distributive property to help me simplify this portion over here. But before I do that, I can write the minus over here like this over here. Now I can further simplify by simply multiplying negative 1 and 18 together to give me a negative 18. And multiply negative 18 with the k to give me a negative 18k. I can further simplify negative 1 times 12j to give me a negative 12j. When I'm adding a negative, that is the same thing as saying I'm subtracting that number. And when I'm subtracting a negative, that is the same thing as saying me adding that number. Lastly, I combine the families of the k's together since the coefficients over here are 4 and 18, and the operation that I will perform is that of the negative due to the symbol over here. I can do 4 minus 18 to yield negative 14. Therefore, I get negative 14k over here plus 12j. Now, before I declare this as my final answer, the only thing that I really need to do is simply put the positive term out in the front and put the negative out in the back. When I do that, I get 12j minus 14k. So now you know how to properly simplify variable expressions, and I hope you learned a lot from this video and you enjoyed it thoroughly. I hope you keep on working hard, and I'll see you in the next video.